right, so here's 2018 number 6 for your recap number 6. It says consider the differential equation dy dx equals 1/3 x times y minus 2 squared. So this is representing the rate of change of y with respect to x is equal to this product. A slope field for the given differential equation is shown below. So they already did the picture for you. Sketch the solution curve. So that's the particular solution that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. So both of these, I'm going to do the blue one first, actually, to talk about. So this one, 1, 0. So I want to go to that point, which they already have plotted for us. And then remember, I talk about in class, you want to follow the winds of change. So this has a positive slope, which means it's going to throw me this way. So I kind of go until I catch that one, and then that's going to throw me like that way, right? Okay, so I'm just following kind of the general shape. If I move backwards to the left, it looks like I'm being thrown down. Okay, I can actually find what's going on at a certain point if I wanted to plug stuff in, but I'm just going to kind of sketch. Looks like I catch a horizontal tangent about there, and then looks like this thing has some symmetry to it. And I think that looks good. The other one, 0, 2, well here's 0, 2. It throws me that way, which throws me that way, that way, that way, that way, that way. Going to the left throws me that way, that way, that way, that way, that way. And this one makes even more sense because if you think about the point 0, 2, anytime y is 2, you're going to end up with a slope of 0. So we end up with just a horizontal line. Now, scoring-wise for this one, they talk about just the general shape. So the purple one, you did for sure have to have a perfect horizontal line. For the blue one, it was something about like the general flow or something is how they described it. Definitely needed to have a turnaround point down here, positive over here, decreasing over here. All right, let y equals f of x be the particular solution with the initial condition 1, 0. So we're going through the point 1, 0, which is the blue one. Let's do that in blue, which is the blue one that we just drew. Write an equation for the tangent line to the graph at x equals 1. Use your equation to approximate f of 0.7. So writing the equation of a tangent line, we know we need y minus something equals a slope, x minus something. We're going through the point 1, 0. And now I need to find the slope at 1, specifically 1, 0. Here's our slope. So dy dx at 1, 0 is going to be equal to 1/3 1 times 0 minus 2 squared. So I get 1/3 times negative 2 squared is 4. So I have a slope of 4/3. So this is the equation of the tangent line. I'm going to use green and show you back on the graph. So this would be the tangent line right here. And we're going to use that tangent line to approximate what was going on when x is 0.7. So I'm going to find this red dot, and it's going to estimate what that blue dot really should have been. So I'm going to plug in 0.7 for my x value. And some of you might be thinking, how am I supposed to do this without a calculator? But AP is actually pretty nice. 0.7 minus 1, 7/10 minus 10/10 is going to be negative 3/10. You could write it as negative 0.3 if you would like. The 3's are going to cancel out. And I'm left with y equals negative 4/10. Or you could say y equals negative 2/5. So what that really was, to write your official answer, you would write f of 0.7 is approximately, I said fifths and I wrote third, is approximately negative 2/5. I just checked the scoring rubric. They also would have accepted negative 0.4 or negative 4/10. All of those things are the same, so you're good. All right, this one is where we actually do all that separation of variables. Make sure you don't get too excited in part B and do all of that work. It never says to find the particular solution until right now. So we're going to find the particular solution. We start, remember, by step 1 is separate variables. So I'm going to take this y minus 2 squared and divide it to the other side. And then I'm going to multiply this dx to the right side. So I get all my x's and dx's on one, all my y's and dy's on the other. Step 2 is to take the antiderivative. So on the left side, technically I need a little u sub. U is y minus 2. Du is equal to dy. So this really becomes the integral of 1 over u squared du equals the integral of 1/3 x dx. Well, this is really just u to the negative second. I'll write that over here just for space. This is really the integral of u to the negative second. So this is going to become u to the negative first over negative 1 equals, this will just be 1/3 x squared over 2 plus c. So let's do a little bit of cleanup work. We got to plug our u back in. So I'm going to have a negative 1 over, this negative 1 will push to the bottom, equals x squared over 6 plus c. Okay, step 3 is technically the plus c, which we did right there. Step 4 is use the particular solution, which in this case was the point 1, 0, right there. So I'm going to plug in the point 1, 0, which will allow me to find c. So this is going to be 1/2 equals 1/6 plus c. I'm going to subtract 1/6. Be strategic. 1/2 is 3/6 minus 1/6 equals 2/6, which is really 1/3 is equal to c. So I found my particular c. Step 5 then is to actually find the particular solution. So I'm going to go back to where I was done with my integral, which is this line right here. Negative 1 over y minus 2 equals x squared over 6 plus the 1/3, that c value that I just found. This says I'm supposed to find y equals, which means that I need to somehow isolate this y value. And this is where oftentimes calculus students get stuck because of the algebra. Don't let that be the case. I'm going to notice right now that I have denominators of 6 and 3 that I could clear out if I just multiply this whole thing, both sides, by 6. So I'm going to distribute a 6 to the right side, and I'm also going to distribute a 6 to the left side. This will be negative 6 over y minus 2 equals x squared plus 2. The next step then would be, I personally think, is multiply by y minus 2, because we need to get that y up in the equivalent of the numerator. So then, remember, I'm still trying to get this y all by itself. I'm going to divide both sides by x squared plus 2. And the last thing then to get the y all by itself would be to add 2 to the other side. Which is really equal to f of x. Okay, you can always check by plugging in the point 1 and seeing if you get 0. So 1 squared is 1, plus 2 is 3. Negative 6 divided by 3 is negative 2, plus 2 got me my output of 0, right? Because the point was 1, 0. This is your particular solution because you separated the variables, you took the antiderivative, you wrote plus c, you used the condition to find c, and then you solved for y. Okay, now there might be some other manipulations with algebra that you can do to get this, all right? Some of you might have other little shortcuts and techniques. That's fine. What I want you to recognize is from this part in red, before I multiplied both sides, this is really like x plus 2 over 1. So you can do a little cross multiply if you like that. You could also remember from geometry days when we do proportions, a over b being equal to x over y is the same thing as b over a being equal to y over x. So from that line in red, when I had negative 6 over y minus 2 equals x squared plus 2 over 1, it is perfectly legal to just flip these fractions. Oop, plus 2. And then solve for y. If you like that better, that's totally fine. Up to you. I do want to point out on the scoring guidelines, though, 1 point just for separating the variables. 2 points, so 1 point each for the antiderivatives, right? The left side needed a u sub, the right side was just the power rule. 1 point for using the constant of integration and that initial condition, so writing plus c and finding c, and then 1 point for getting y all by itself. If you don't separate variables, you don't get anything. If you don't write plus c, you don't even get the other points. You get 3 out of 5 and that's it. So it's really important that you get used to this kind of step-by-step thing, but also super important only when it says find the particular solution. A lot of you do this way too soon in the problem. Wait until you see the directions. Find the particular solution. All right, the one that we have for you to practice is 2017 number 4. It's a story problem dealing with a potato. Potato's gonna potate. Dealing with a differential equation. So the answer key for this is up. This one also, there's a ton of YouTube videos about that have already been made by teachers. So of course, we're happy to answer your questions. If you want to set up a Google Meet about the baked potato, you can use the scoring rubric as something to work backwards from if you get stuck, but also probably a good idea to watch a video because this is more the trend of like a story problem being all put together with a differential equation, kind of like the baby bird from a while ago. So hopefully that helps, and we'll see you next time. I was saying potato is gonna potate, and then I cut myself off on my recording. It's just one of those days. Bye, guys.